So dear students, so in your exam is very near. So in exam everyone will be given one ECG. Okay, so just what will be asked during exam, that points, that questions, and just for your basic knowledge few lines I will tell. Okay, so specifically that this video is for my first MBBS students, okay, and those who like my videos. So let's start. So in the exam it will be given exactly like this. Okay, you know there are 12 leads that I have explained you. So after giving this, the question will be asked, what is this? Then you should answer it like, say, so this is an electrocardiogram of a person during resting stage, or you can say this is a 12 lead electrocardiogram in resting stage of a particular person. Okay, that means 12 lead you have mentioned, resting state, yes, Holter monitoring is another one. This will be so long, no, it will be about a bundle of papers. So here, and in a resting stage, subject is not in treadmill. Okay, we are in resting state, ECG is taken. So here you see this lead 1, lead 2, lead 3, at least 3 wave. There is a rule that is that the 3 QRS complexes you have to take in each lead. Okay, so here this is a patient's ECG. It is done not here, it is done outside. Okay, not in Barak building, and many abnormal things are there, but just I want to get all the get exactly like what we have in our department. So I took the ECG. So you know the basic waves. When current passes from SA node to AB node, so first atrial depolarization which produces the P wave. So briefly, P wave is, remember, P wave width 2.5 small square, okay, 2.5 small square, and height, that is the amplitude, 2.5 small square, and it is a curved one. It cannot be notched, it cannot be pointed. Okay, it is only inverted. It is always positive deflection except in AVR, augmented voltage lead in the right. Okay, so then QRS complexes. Okay, here QRS complexes, this is actually factor, and this how current is developed better it is given in your book, so I will not go that much details. Okay, that QRS between the P wave and the beginning of the QRS complex, that interval is called the PR interval. Okay, that PR interval is, it is asked during exam. What do you mean by PR interval, or can you tell me the P, what is the PR interval? Okay, so you have to know what is PR interval. Then normal PR interval is 0.01 to 0.02 the second. And PR interval means it is the time taken by the impulse or action potential generated in the SA node to reach the ventricular musculature, okay, via the AV node. And there is a AV nodal delay. Okay, AV nodal delay is very important, because if there is no AV nodal delay, atria will also contract, ventricle will also contract simultaneously. Then ultimately, cumulatively, just like ventricular fibrillation, there will be no cardiac output. So after contraction of the atria, ventricle should be in relaxed position for some time, because it needs to be filled. That's why the AV nodal delay. AV nodal delay, here just you remember one point, there are less gap junctions. Okay, fibers are very thin fiber and less gap junction. These 2 points you remember, that is enough for you. And so QRS complex, if you want to go the 3 waves, Q wave is because of the septal depolarizations, R it is because of this left ventricular depolarizations, and S it is because of the right ventricular depolarization. Actually R and S, there you cannot differentiate. This is that only left ventricular depolarization, this is only right ventricular depolarization, that cannot be differentiated. When this QRS complex generate at the very early part, the left side of the septum, the middle half first get depolarized. Okay, that produces the first part of the Q wave. And simultaneously the endocardium of both the ventricles then depolarizes. Okay, so these are some basic points, you remember it. And one more question is asked, show me the waves. So you better show, here is an ECG wave tracing, so this P wave, Q wave, RS and T, and here is the ST segment. ST segment is, it is the part between that is ending of the QRS complexes and before beginning of T wave. T wave means repolarization of the ventricles. Here atrial repolarizations get submerged under the T wave, so we get only one wave. In this case, this ST segment is very important because this is the isoelectric point. At this point, the heart is electrically neutral. All the ventricular, all the atrial muscle has depolarized. Now there is a pause, then they are about to repolarize. So there is no current. So it should be flat. If there is any elevation depression, that can to be abnormal. So that is the importance of the ST segment. And T wave, it is the repolarizations of the ventricles. Okay, here atria also depolarize, and it is sometimes you can see as a separate wave. That is a different thing. Now in this ECG, say one more thing you have to know, this bipolar lead and this augmented lead. This lead, it measures or it measures the potential differences or current generated during heart in the vertical plane, and this SES lead, okay, it measures the potential difference or electrical activity of the heart in the horizontal plane. Okay, so these QRS complexes, so if you go from V1 to V6, okay, so V arrangement of the heart is like that. The ventricle is placed a bit in the left and a bit posteriorly. Okay, so the R wave, which is because of the left ventricular depolarization. So definitely R wave will be say bigger and bigger if you grow from V1 to V6, and simultaneously S wave will become smaller and smaller from V1 to V6. Okay, because you are going away from right ventricle, so it gradually it will become smaller, and that is in V1 the biphasic pattern, gradually it will take this R wave, tall R wave will be there. And R wave it may vary up to 25 millimeter, 25 small square. ECG paper, these are small, it is divided in smallest square and small square. The small squares are having 5 millimeter length and 5 millimeter breadth. Okay. So now another one point that after that I will end this video. Okay, that is asked, calculate the heart rate. So you see the paper is moving when you tracing the ECG. Paper is moving at the speed of 25 millimeter per second usually. Okay. So say you just see, so there is one QRS complex. Suppose there is one R wave, ventricular contraction. After some time, another R wave came, then ventricular contraction. What do you mean by heart rate? In 1 minute, that is 60 seconds, how many heart contraction comes? Okay, so in 25 millimeter, in 1 second, the paper moves 25 millimeter. Okay, so in 1 second, the paper move 25 millimeter. In 60 seconds, the paper will move 25 into 60, that is 1500 millimeter. Okay, so 60 seconds the paper will move 1500 millimeter. So in 1500 millimeter, how many heart contractions are there is equal to heart rate per minute. Okay, so now say one R wave and between two R wave, suppose there are X number of small squares are there. Okay, then X millimeter gap is there. So one heart contraction is coming at X millimeter interval. Okay, so in X millimeter interval, heart contraction coming is 1. So in 1 millimeter interval, heart contraction is coming as 1 by X. Okay, and say in 15,000 millimeter, so 1500 millimeter, how many heart contraction will come? So 1500 millimeter heart contraction will come as 1500 millimeter divided by X in numbers. That means, so if you want to conclude it, how you can calculate the heart rate? Say number of small square. Okay, one small square is equal to 1 millimeter. Forget that 1 millimeter. You take small square, number of small square between two consecutive R wave, and divide 1500 by that number of small square between two consecutive R waves. Or you can do another one thing here. In 60 seconds, the paper will move 1500 millimeter. So you can say, you can divide it by 5. So if you divide it by 5, that means here smallest square we have to take it the large square. Okay, because 5 small square is equal to one large square. So if you divide it to 5, then you will get 300. In 60 seconds, the paper will move 300 big square, which is of dimension 5 millimeter by 5 millimeter. Okay, so in that case, suppose there are y number of big square, y number of big square is there between two R wave. Y number of big square interval, one heart contraction comes. So in one big square interval, how many heart contraction will become? It will be the 1 divided by y. Okay, so in 300 square, 300 big square, 300 big square, how many contraction will come? 300 divided by y. Okay. So, if between two there are, say, suppose 10 small square are there, so heartbeat will be 150. Okay. So, T wave is I have told already, repolarization, and repolarization, you know, potassium plays a key role in repolarizations. So, T wave will be prolonged, very low, high amplitude during, say, hyperkalemia. Okay, it may be of low amplitude during hypokalemia, and there is a P wave abnormality in COPD. P wave, there will maybe a big tall P wave, more than 2.5 small square diameter, and that is called P pulmonale. Okay. Then if the PR interval is more than 0.01 to 0.02 second, then it will be block. There are different type of block, MBBS type 1, type 2 block, and different type of there is different type of block, AV block, or there may be a junctional rhythm, that is that AV node is taking the upper hand. In that rhythm, if you see in a lead, particular lead, okay, if you see junctional rhythm, then there will be what will be there, because SNOD is not producing the impulse. So, P wave you will not see, you will see QRS complexes, okay, and idioventricular rhythm, that is called only this specifically the QR wave type of things you will see, okay, and if a rate is more, that is called ventricular tachycardia. Okay. So, thank you very much and best of luck.